On with the 6-7 guide, finishing up the 7 part. The part B is really just an exercise for you guys to go through, not much I can teach there. So I'm going to finish up with 7C, which is really just an extension of what we did the other day. Okay, so just as a review of what we did the other day, let's determine F circle G at X. Just so that we're familiar with the notation, okay, and the different notation on the test. Remember that F circle G of X means the exact same thing as F circle G. Okay? It doesn't mean F circle G times X, it just means of X, which in turn ultimately means F evaluated at G of X. So with all composite functions, whether we're working with a discrete function or a continuous polynomial function, we start with the inside and we work our way out. So the first thing I want to do is I want to replace what G of X is equal to. And G of X is equal to 2x squared minus 6. So I'm going to replace that. And then, what do I do? So I want to figure out what f of 2x squared minus 6 is. How do I do that? Or what do I do? Alex? Perfect. Okay, so I write down the f of x function, which is -2, but instead of writing x, I replace the x with what's inside of the bracket. Now it's a matter of expanding and simplifying. Again, I want the answers expressed in standard form, so that means put the exponents from the highest exponent down to the lowest exponent. -2 times -6 is 12, add 5 is 17. Okay, any questions on that? Okay, so let's do P circle P. So remember, P circle P means P evaluated at P of X. So probably a good idea on your test, especially if you're kind of struggling with the concept, is to rewrite it for what it means. So this means P of X evaluated at P of X. So the first thing I'm going to do is replace what P of X is equal to. So P of X by definition was X plus 3 over 2X minus 1. So now I'm going to take what's inside of the bracket, which is X plus 3 over 2x minus 1, and substitute it into the P function. So everywhere I see an x, I'm going to replace with what I had inside of the bracket. So I would write x plus 3 over 2x minus 1 goes in for the x, plus 3 over 2, but instead of writing x, I'm writing down what's inside of the bracket. And then finishing. Any questions on that? Because that's just doing the substitution. Now it's a matter of simplifying this rational expression. So to simplify the rational expression, I'm going to need to find a common denominator. So the common denominator on the top is 2x minus 1. So I need to multiply 2x minus 1 on the bottom here, and if I do that, I have to multiply it on the top. That makes sense? Finding common denominator? Same thing on the bottom. But before I find a common denominator, I'm going to distribute this 2 inside of the bracket. When I distribute the 2 inside of the bracket, so I multiply the top by 2, the bottom by 2, the top and the bottom by 2. How do I do that? Lucas? Right, just the top. Okay, so I'm still getting people saying, okay, there's a 2 here, I'm going to multiply it to the top and the bottom. Remember, 2 is just that fraction 2 over 1, and when you multiply fractions, you multiply the tops and you multiply the bottom. So I would get, distributing that 2 through, I would get 2x plus 6 over 2x minus 1. Subtract, finding a common denominator, 2x minus 1. I multiply the top by 2x minus 1. Any questions so far? Okay, so now I'm going to distribute out the top, so I get x plus 3. Multiplying this 3 inside of the bracket, I get 6x and minus 3. And since I have a common denominator, I can combine it into one fraction now. Does that make sense? Okay. The bottom would become 2x plus 6. And I'm going to do a common mistake, and somebody's going to tell me what it is. That. Look at exactly. Remember that this negative doesn't just belong to this 2x, it also belongs to this negative 1. So if you forget that, it might be a good idea to put it in brackets, okay? So that you distribute this to here and to here, making that a plus 1. Okay, so now we're ready to collect some like terms. On the top, I have 7x plus 3 minus 3 cancels out over 2x minus 1. And on the bottom, I get 2x minus 2x is 0. Add, I get 7 over 2x minus 1. So I have a fraction divided by a fraction. And when I divide fractions, I invert and multiply. Which one do I invert? Does it matter? Which fraction do I do? The first one, second one, both of them? Does it matter what I do? It very much matters. Okay? Which one? The second one. Always the second one. Okay, so the first fraction always stays how it is. And flip the second fraction, because that's what you're doing when you're inverting. And I get that. Okay. Whenever you're multiplying fractions, always look to see if you can cross out or divide through any common factors. Is there anything common on the top and the bottom of these two guys? Yeah,
2x minus 1.
right. So 2x minus 1 goes into 2x minus 1 one time. Anything else? Lucas? Right. So 7 goes into 7. That leaves me with that. Any questions on that? Okay. So that was what? The second example we did? I can figure out a composite function of a composite function of a composite function. I can do that as many times as I want. Let's just practice doing 3 of them. So F circle G circle H, okay, means F evaluated at G, evaluated at H. And the round brackets, square brackets, they don't mean anything different. They just looks nicer, I think. So with composite functions, you always start with the inside and you work your way out. So the first thing I'm going to do is replace what h of x is. And h of x was the square root of 3x squared plus 4. That make sense? Okay. Then what I'm going to do is I'm going to take that square root of 3x squared plus 4, substitute it into the g function everywhere I see an x. So the g function was 2x squared minus 6. So it becomes 2. Instead of writing x, I'm going to write down what was inside of the bracket. Then I square and I subtract off 6. Okay, so all I've done is I've taken this and substituted it into the g function and replaced with the x. We good? Okay, I have two options now. Option number 1 is I can take all of this and substitute it into the f function everywhere I see an x. Option number 2 is I can simplify this and then substitute it. It doesn't matter, you'll get the right answer, whatever you feel like doing. Okay? I usually like to simplify before I move on, because I think it'll make life a little bit easier. So 2 times the square root of 3x x squared plus 4 squared minus 6. So because of BEDMAS, I do the exponents first. What is the square root of 3x squared plus 4 squared work out to be? Right, because square rooting something and squaring it is opposite operations. You'll end up with the same thing. So you end up with 2. Remember to keep it in brackets. The answer to that. Now it's just a matter of simplifying inside here. 6x squared. 2 times 4 is 8, minus 6 is 2. And then you take that and plug that into the f function. So the f function was negative 2x plus 5, but I'd write negative 2 instead of writing x. I write down what's in the bracket. And then I simplify. That times that is 4. Add to 5 is 9. Any questions on that? Sound good? Okay. D. Does anybody recognize this? And if so, can you tell me what it is? Oh, I probably did. And I'm all confused. What happened?
The second line there.
This one?
It should be plus 2, not minus 2.
Oh, yeah, thanks. So then that becomes minus 4, right? And that becomes 1. Thanks, Lucas. Now we're all good? Okay, going back to before I screwed up, or after I screwed up. Does anybody recognize what that is? John? Okay, so it looks like a negative exponent, okay, but it's not. It's notation for what? There. It's an inverse function. Okay. So an inverse function from back from grade 11. So I'm going to write down the f function, which was y is equal to negative 2x plus 5. And I want to come up with the inverse of this function. Does anybody remember how to do that? Yep. Perfect. First thing you do is you switch the x's and the y's. Nothing mathematical about that. Just where you see an x, put a y. Where you see a y, put an x. And then what do? Okay. Right. And then you isolate your y. So x, putting the 5 across, becomes, divide both sides by negative 2. And I get x minus 5 over negative 2 is equal to y, which is my inverse function. If I don't want that negative in the bottom, how can I get rid of it? We've talked about this before, but I think some of us have forgotten how I can get rid of negative denominators. Yeah? Okay, so you can't multiply the top by the negative, so you're going to change the value of it, right? So you might be knowing how to do it, just not how to say it. Anyone else want to take a stab at it? Kyle, you look like you want to say something?
Well, if we divide, then we just make it into like over terms, so we can divide.
But if you divide, you're going to end up with decimals. I don't want decimals. Right? All I want to do is get rid of this negative right there. That's all I want. How do I do that? So you're saying multiply. I can't multiply by negative, but I think you're saying it right. You're just not saying it right. Nick, were you going to raise your hand? And then I can't just do that. Right? Yeah, good. Okay, so you can multiply the top and the bottom by negative, because a negative and a negative would be a positive. So you're multiplying by a positive, well, you're not changing the value, just the look of it. But really, if you remember, I talked about a while back that if I have a negative in the bottom of a fraction, I can just take that negative and move it to the top. Or I can put it out in the front. As long as that negative is associated with the fraction, it doesn't matter where it goes. So if I take this negative and move it to the top, remember that the top was in brackets. So that would be the inverse function. And then if I wanted to even simplify it even further, it'd become negative x plus 5 over 2. And that was my inverse function. Okay? Okay. So now that we have the inverse function, I'd like you to do this. So the exact same stuff we're doing, now we're just doing it with the inverse function. Okay, so f circle f inverse means f evaluated at the inverse of f of x. First thing I do is I replace what the inverse of f of x is. We just figured that out, which was negative x plus 5 over 2. I take that and I substitute it into the f function everywhere I see an x. So it becomes negative 2. Instead of writing x, I'm writing down what's in the bracket. And then I write down the rest of the f. Okay. So now it's time to simplify. 2 goes into 2 one time. Then I distribute that negative 1 through. Negative 1 times negative x is positive x. Negative 1 times positive 5 is negative 5. Plus 5, which works out to be 0, and I end up with that. Make sense? Okay. EF. So now let's do the inverse of the function. So this is f inverse evaluated at f at x. So f of x was negative 2x plus 5. Now we're taking that and plugging it into the inverse. So the inverse was negative x plus 5 over 2. So I would write negative, instead of writing x, I write down what's in the bracket. Plus 5, and that whole thing is over 2. Okay. Simplifying on the top, distributing the negative through, I get 2x minus 5 plus 5 is equal to 2. Excuse me, over 2, not equal to 2. Plus 5 and negative 5 make 0. 2x divided by 2 is x. So these answers working out to x is not a coincidence. In the first example I did, it was a coincidence. It just happened to work out like that. But whenever you take a composite of a function with its own inverse, it has to be its own inverse, the answer is always going to be the domain of the function, the original answer. Okay? Now, you may remember, you've been doing this all through high school in trigonometry. So if I asked you to figure out what angle x was, what would you have to do to get angle x? What button did you have to hit in your calculator before you hit the sign button? Anybody remember this? Right, exactly. You hit the inverse function. So really what you're doing is you're taking the inverse of both sides. And this is a composite function. This guy undoes that guy, and that's how you end up with just having x. Okay, so you've been doing it all along. So any single time you have a composite function with its inverse, and it doesn't matter the order, that's why I showed you both ways, the answer is always going to be x. So on a test, perhaps, you might want to star this, you might get a question like this. So P circle P inverse of x. P was a pretty scary function, it's way back here. It's a rational function. If you go ahead, find the inverse of this, take the inverse, substitute it into the original function, you will get the same marks as somebody who remembered Mr. Potvin saying that answer is x. Okay? Any questions on that? So it doesn't matter what the value is here. If I ask you, we had an h function. What do you think the answer to that question is? Okay. Negative 5. And again, it only works if it's the same function. So if this was h inverse circle g, then you have to do all the work. Okay? But if not, then it's always equal to the domain of the function. Since we're working with polynomial functions for the most part, except for that one rational function, the answer is always going to be x, because x is the domain. Okay? Any questions on that? Okay, so then the last thing we have to do is talk about discrete functions. Given the function -2 and 1, -1 and 2, 0 and 3, 1 and 4, determine, yeah, good luck, eh? Oh, my old team. Okay. So now we're doing discrete functions, just a reminder of how we evaluate discrete functions. If I want to find the inverse of a discrete function, how do I do it? Are you raising your hand? Exactly like we did before, where we switched the x and the y values, but here you're just actually physically switching the y and the x values. So to find the inverse, as long as you can take two numbers and rearrange them, it should be fairly easy. Okay, so to find the inverse of a discrete function, just switch the x's and the y's. Okay. This one requires a little bit more work. So this is the discrete function. So the discrete function, right, it only has certain values for its domain. So the answer for this just isn't x, right, because it's a whole different function. What we need to do is that whole thing that we did the other day, where we have to start with a number, figure it out, and then I did all that rough work, but then I showed you a quicker way of doing it. So when I'm working with f inverse of x, which function do I work with? Start with? Which domain do I start with? The inverse guy or the f guy? Right. Always start with the inside, work your way out. Okay, so I'm going to start with the x values of this guy, figure out what the y value is, and then go up here and figure out what the corresponding y value is. So I'm going to do it without doing all that rough work. So I'm starting with the inverse function because it's the inside one. I'm starting with 1. 1 became -2, so I'm looking up here where I get a -2. -2 becomes 1. So I started with 1, and I end with 1. Next one. The next x value is 2. 2 became -1. -1 became 2. So my next one is 2 and -2. So really, it's the same thing as we talked about with the polynomial functions. You do end up with the domain. So whatever you start with, you're going to end up with. So you don't even have to do any more math. What's that answer going to be? Yeah. No, 3. Okay. The next one, you started with 4. You'll end up with 4. So remember, for a discrete function, it's a set. The answer is always a set of points. Okay. For polynomial functions, the answer is always equal to the domain. Okay, so that should give you way more than enough skills in order to be successful on the test, which is due tomorrow.